Hello, this is Mario, and welcome to Awesome Audio. In this video, we will be talking about fundamentals of electricity.
It's important that we talk about electricity, since we use electricity to pick up, reproduce, modify, and store sound, and soon we will be touching upon topics that involve the use of electricity. First, let's talk about current, voltage, and resistance. Electric current is a flow of electrons that travel through a conductive material such as a copper wire. However, individual electrons do not travel long distances. The wire is made of atoms, and current is produced when an electron arrives at an atom, then that atom sets an electron free, and afterwards, that electron arrives at a nearby atom, which sets another electron free. So current is more like a chain reaction of electrons passing from an atom to the next. Electric current intensity is measured in amperes, which describes the amount of electric charge that passes through a point in a second. Commonly, atoms are electrically neutral. That means that they have the same amount of protons with positive charge in their nucleus than electrons with negative charge in their layers. Positive and negative charges neutralize each other. If you add electrons, the atom will have more electrons than protons and therefore will become a negatively charged ion. If you take out electrons, the atom will have more protons than electrons and therefore will become a positively charged ion. Only electrons can be added or removed, but it is not possible to add or remove protons. I'm taking this chance to mention that the structure of an atom has never been seen with detail. These drawings of atoms are only models, or graphical representations, that allow us to understand the behavior of an atom and therefore have been useful to us in physics and chemistry, but it doesn't mean that they literally have that aspect. A battery has two terminals that are not connected to each other. In the negative terminal, there is an excess of electrons in its atoms, creating a negative electric field. And in the positive terminal, there is a lack of electrons, creating a positive electric field. This imbalance creates an electric tension, called potential difference, or voltage, which is measured in volts, and will be larger the greater the charge imbalance there is in its terminals. When connecting both terminals with a conductive material, electrons, which have a negative charge, will be attracted by the positive electric field at the other terminal, just as magnetic opposites attract, and they will flow through the connection.
We can imagine the voltage of the battery as the force that pushes the electrons, although it is not too accurate to describe it that way.
A battery is considered depleted when the amount of electrons and protons in both terminals becomes balanced, and recharging a battery essentially means returning electrons to the negative terminal, unless we're talking about a car battery which functions under a different principle that I will not explain in this video. Due to a historical error, current is always mentioned to flow from the positive terminal to the negative one, which is called conventional current, since this is how current was originally thought to flow. However, here we see that electrons actually flow from the negative terminal to the positive one, which is called electron flow. For circuit analysis, it is more common to use conventional current, which is what I will be using in this video. A resistor is a component through which electric current may flow, only less easily than through a conductive material. They're basically used in a circuit to control the current intensity going through the circuit, since connecting the terminals directly can cause an uncontrolled current that would rapidly deplete the battery, or that may burn other components. Resistance is measured in ohms. With these three elements, we form Ohm's law, which is the equation that tells us that the current in a circuit will be proportional to the voltage of the source, and inversely proportional to the circuit's resistance. That is, the greater the voltage, the greater the current, and the greater the resistance, the lesser the current. If we have a circuit with a 10-volt source and a 5-ohm resistance, a 2-ampere current will be produced, which is approximately 12 quintillion electrons flowing through a specific point in the circuit each second. A series circuit is a circuit with elements connected one after another. In this case, voltages will be generated at the components' terminals, in the direction opposite to the voltage of the source, and the sum of these voltages equals the source voltage. These voltages at the components may be interpreted as the effort that it takes for the electric charges to go through the component, due to its resistance, but it doesn't mean that the components become sources of voltage. The current in the circuit is found by summing the resistor's values, giving us an equivalent resistor, and using Ohm's law like we did in the previous example. In a parallel circuit, each end of all components are connected to a single point. In this case, it is current that distributes and not voltage. To find the total current, the equivalent resistor is found through an inverted sum, and then Ohm's law is applied again. Alternate current is produced when the voltage of the source is varying in a way such that it goes to negative values, changing its polarity. This causes the current in the circuit to be varying its intensity and direction. In point 1, the source of the voltage reaches its maximum value. In point 2, it begins to decrease. In point 3, there is no voltage. And in point 4, a negative voltage starts to increase, which generates a current that advances in the direction opposite to the current in points 1 and 2. For example, in North America, the voltage in a common household plug is alternate, varying in the form of a sine wave with an approximate amplitude of 170 volts and a frequency of 60 Hz. That is, the cycle repeats 60 times per second. However, due to the varying magnitude, the voltage is not always at 170 volts, which is why it is preferred to mention the mean voltage in a semicycle, the famous 120 volts, although technically those are not normal volts, but volts RMS. In a circuit that only has resistors, the current at a specific moment would equal the voltage in that instant divided by the equivalent resistance of the circuit. When we see a wave, it is important to know when we are seeing an electric signal and when we are seeing an acoustic wave. In an acoustic measurement, the middle line represents the natural atmospheric pressure. The upper part represents higher pressure due to air compression, and the lower part represents lower pressure due to air expansion. This may be identified by observing the vertical axis. If it shows voltage, then it's for an electric signal, while if it shows pressure, then it is an acoustic wave. With that, we conclude this episode. In the next one, we will talk about the use of the decibel and different types of decibels. If you enjoyed this episode, you may hit like, leave a comment, or share to those interested. For more content like this, you may also subscribe. See you in the next video.